Hey everyone, hope you are having a great day. Welcome back to my channel, Marky Salo Vlog. In today's video, we're going to discuss an important topic, the different types of coordinate systems. Understanding this coordinate system is crucial for accurate positioning, especially in the concept of celestial navigation. In today's video, we're going to explore the Earth coordinate system, equinoctial coordinate system, horizon coordinate system, and the time diagram. Throughout history, this coordinate system have been fundamental in navigation, allowing mariners to locate their position accurately on Earth. So let's go. Let us explore this. The primary component of Earth coordinate system is the polar axis, an important reference in celestial and terrestrial navigation, representing the imaginary line which Earth rotates, passing through the North and the South Pole. It is relative to the plane of ecliptic or the Earth's orbital plane around the Sun. The tilt of Earth's polar axis relative to this plane is approximately 23.5 degrees, and this tilt is responsible for changing seasons experienced in different parts of the world. Next in line is the equator, which serves as primary great circle in the Earth's coordinate system. It is perpendicular to the polar axis and divides the Earth into two equal parts, the North Hemisphere and the South Hemisphere. Equator marks the point of 0-degree latitude and serves as the reference line for measuring distances on Earth. Latitude is the angular distance from the equator measured northward or southward along a meridian from 0 degree at the equator to 90 degrees at the poles. Latitude is sometimes called as parallel for the term parallel of latitudes. The last components in Earth or geographical coordinate system are the meridians. Meridians is simply known as the longitude, or longitude and meridian is the same term. The only slight difference is that meridians are measured from 0 to 360 degrees without name, while longitude measured from 0 degree to 180 degrees with names, east or west. Meridians are imaginary lines on the Earth that run from the North Pole to the South Pole. Here are some examples of different types of meridians. First is the prime meridian. Prime meridian is the meridian designated as 0-degree longitude from which all other meridians are measured. It passes through the Greenwich, England, and serve as the baseline to determine west hemisphere or the west longitude and east hemisphere or the east longitude. Longitude is the arc of a parallel or angle at the pole between prime meridian and a meridian of a point on Earth measured east or west from prime meridian 0 degree through 180 degrees. Opposite to 0 degree meridian or the prime meridian is the 180-degree meridian, which is more commonly known as the IDL or the International Date Line, also known as the anti-meridian. To summarize the parts of Earth coordinate system, simply refer to the figure. Once again, the main purpose of this Earth coordinate system is to locate or to pinpoint our location on Earth. You know what, guys? The reason I love celestial navigation because I can show the whole Earth or even the entire universe by just a simple circle. Yes, you heard it right. Isn't that cool, guys? Diba astig? So, before I discuss the celestial coordinate system and the horizon coordinate system, I'll take this opportunity to explain first the difference of longitude or the DLO, difference of latitude or DLAT, and the co-latitude, since it is still part of Earth coordinate system. And actually, right now, I am sharing to you my technique so that we eliminate the traditional way of memorizing things and to add up this technique to our stock knowledge so that the retention of the lesson will at least be longer or even last a lifetime. The first technique on the list is we need to know the basic, the fundamental, and the concept of particular topic. Basic concept serve as a building block upon which more complex ideas are constructed. Secondly, we need to draw. Drawing is important so that we have the visual. And lastly, we need to apply keywords or acronyms. One of the example of famous keyword here in navigation is the Can Dead Man Vote Twice or the CDMVT for the gyro compass error computation. And for the intercept method, we apply the acronyms of GOAT for Greater Observed Altitude Toward. If we combine all these together with constant practice, we can achieve a best outcome and we apply it in our work and in different type of examination. Since we knew already the basic components of Earth coordinate system, let us apply the second technique, which is the drawing. Each time we have problem solving, this will become a big help. I have here an illustration of Earth. Here we assume that our mini Earth is like a map and a compass. Map because we need to determine and plot the coordinates of a given position. To do this with ease, we need to divide our mini-map or mini-Earth into four quadrants. So from the illustration, this will be the first quadrant, second quadrant, third quadrant, and the fourth quadrant. First quadrant has northeast component or northeasterly name, meaning if the given latitude is north and the given longitude is east, we simply plot it here in the first quadrant. The same principle applies to the other quadrant as well. Second quadrant has southeast component or southern east name. So if the given latitude is south and the given longitude is east, we plot it here in the second quadrant. On the third quadrant, it has southwest component or southwest name. So if the given latitude is south and the given longitude is west, we plot it here in the third quadrant. And lastly, the fourth quadrant has northwest component or has northwest name. So the given latitude is north and the given longitude is west. We simply plot it here in the fourth quadrant. Now, let's have a sample problem. The given are in two positions, position A and position B. Position A is our initial position at latitude 25 degrees north and longitude 100 degree east. For position B, or our final position, is at latitude 35 degrees north and longitude 070 degree east. We are required to find the DLAT or the difference of latitude and the DLO or the difference of longitude. So before we answer this particular question, let's define first what is the meaning of the DLAT and the DLO. DLAT is an acronym for difference of latitude, while DLO is an acronym for difference of longitude. DLAT is simply the difference of two latitude points on Earth or the two parallels, while DLO is the difference of two longitudes or two meridians on Earth. For operation, we use subtraction and addition. Although in mathematics, if we ask to find the difference, the operation will automatically minus. But here in navigation, we use both. The rule for finding DLAT is if latitude 1 and latitude 2 are same names, we use minus. If the latitude 1 and the latitude 2 are different names, we add. Same goes in the operation of finding DLO. We minus if the longitudes are same names, and we add if the longitudes are in different names. For naming or labeling DLAT, it's either only north or south. North means the 00 degree true, and south meaning the 180-degree true, while for naming the DLO, we used east or west. East or the 090-degree true, and west the 270-degree true. For the drawing or visual, all vertical lines are regarded as the DLAT, and all the horizontal line will be the DLO. The maximum value for DLAT is 180-degree north or south, while the maximum value for DLO is at 180 degrees east or west. If the value of DLO exceed 180 degrees, then we need to minus 360 degree, then label or name according to the true course, east or west. Of course, we are truly marineros. We used to plot the position of our vessel manually in the nautical chart or directly using our ECDIS. But today, we will learn how to plot in our mini Earth using best estimation. Since the given latitudes are both in north and the given longitudes are both in east, we simply plot the coordinates in the first quadrant. Using the sailing triangle concept in navigation, if there's 2 points on Earth, we just need to connect them to get the true course and distance. But this concept is advanced. I will make another video about sailing triangles, but it's still relevant also in celestial navigation. So we will touch only the basic. Remember the rules for difference of latitude. It is the vertical lines, north or south. Since the position B is at higher latitude compared to position A, our DLAT will be named north. This is how we draw this. From the tip of our DLAT, we draw the horizontal line for DLO. Remember, DLO is named west or east only. From the drawing, it is obvious that we need to travel westward, to be able to arrive at position P. That's the first technique. I hope it's clear. Now, the second technique. Through the two parallels of latitude to get the DLAT. The red broken lines represents parallels of latitude 35 degrees north and 25 degrees north. According to the rules of DLAT, if the latitude have same names or label, we subtract or minus. But remember, no negative answer. So we need to subtract greater value to lesser value. So in this case, latitude 2 will be subtracted from latitude 1. So latitude 35-degree north minus 25-degree north, the answer will be 10 degrees north, or our DLAT is 10 north. The final answer for DLAT should be in degrees or in nautical miles. If we want the value in nautical miles, we simply multiply 10 degree by 60 minutes, since 1 degree of arc is equivalent to 60 nautical miles and 1 minute of arc is equivalent to 1 nautical mile in latitude scale. The answer will be 600 nautical miles. Remember this DLAT in vertical line? If we plot this exactly in the nautical chart, the length of this vertical line or the DLAT line would be 600 nautical miles. For solving DLO or difference of longitude, we need to draw horizontal lines between two meridians. Initially, we are from 100 degree east. We travel westward to 0.75 degree east. In the illustration, it represents the blue broken lines. Meridians are measured from poles to poles. So longitude 1 is equals to 100 degree east and longitude 2 is equal to 75 degree east. According to the rules of the DLO, if longitude have same name, we need to subtract or minus. So the answer will be 25 degrees and the name will be west since our course is westward or 270 degree. And if we want to convert it in nautical miles, we just need to multiply it by 60 minutes. 25 degrees times 60 minutes, it is equal to 1,500 nautical mile. And the length of the horizontal line or the DLO line, if we're going to plot it in the nautical chart, will exactly 1,500 nautical miles. The other way to double check if our answer were correct, we simply look at our drawing as if it is a compass. If our vessel travels from point A to point B, the true course will be at northwest. We know we're in the fourth quadrant. And for the purpose of estimation, let's say our true course is at 315 degree true. A true course of 315 degree true as per compass has northwest component. The north represent our DLAT and the west represent the DLO. Again, this helps us feel to sure that our answer is correct. So that's it. But in the next example, I will teach you the more simpler way or simpler method. Actually, we need to solve DLAT and DLO one at a time. That's the secret. One problem, one drawing. Okay, let's proceed to the next example. Okay, let's have our second example. This time we're going to find or to solve the DLAT with different name. Like what I said earlier, we're going to solve it one at a time. So one problem, one drawing for the given our latitude 1 or initial position at 05 degree north and our latitude 2 or final position is at 08 degrees south. And according to the rules of DLAT, if they have a different name, so we're going to add. So 05 degree north plus 08 degree south, the answer will be 13 degree south. it's very obvious that the parallel of the 0.5 degree north, we're going to 0.8 degree south and will give us a true course of 180 degree true. So the answer will be south. And if we want to convert it in the nautical mile, we just simply multiply 13 degree to 60 and will give us 780 nautical miles. And if we're going to plot it straight in the nautical chart, that vertical line is 780. Okay, for the third example, we are going to find the DLO with different name. So the given is longitude 1, or for our initial position, 00 degree west, represented by the blue broken lines. And for position 2, 005 degree east. So we have a different name, so we're going to add. So the answer will be 008 degree east, since the heading will give us an east, or 090 degree true. And if we want to multiply it, we're going to multiply it by 60 to give us a answer in nautical miles. So the answer will be 480 nautical miles. Okay, for the fourth and final example, we're going to solve for DLO with different name. But the condition is our DLO is more than 180 degree. First of all, this kind of scenario happens when our vessel is passing the IDL, or the international date line. So for the given, our initial position is at longitude 178 degree east. In the drawing, it represented by the red broken line region. I label it position A. And we're going to longitude 2, or for our final position is at 178 degree west, represented by the red broken line meridian. And I label it position B. So it's obvious that our longitude have different name. So the operation will be plus 178 degree plus 170 degree will give us 300, or the answer is 348 degree. According to the rules of DLO, the answer should not be more than 180 degree, and if it exceed 180 degrees, we need to minus 360 degree. So 360 degree minus 348 degree is 12 degree. So our DLO is 12 degree and the name is east. So why did it become east? Actually, um, it's very obvious in the drawing. For initial position A, the course or our heading is 090 degree true. So east, and when we arrive at position B, we are facing east. So it's very clear that the name is east, and we need to, or if we want the answer in nautical mile, we multiply 12 degree by 60 minutes. So the answer is 720 degree nautical miles. That's the distance we travel.